Bismillahirrahmanirrahim. Assalamu alaikum everyone. So today what we're going to do is we're going to continue with lesson number 3, and as you have seen, lesson 3 is quite a lengthy one. Already the lecture for the previous one was an hour or so, and this one it's very similar. Okay, so you're learning an incredible lot of algebra as you're going through this. If you didn't understand something as far as that previous lesson is concerned, what you want to definitely do is re-watch the lecture. I've put additional videos for you to watch. Make sure you look through the homework solutions. There might be many things that are confusing you, and not necessarily to do with the lesson, because of which you might be struggling with lesson 3 part 1, right? But we do need to continue though with lesson 3 part 2. All right, so bismillah, let's get started. So in this lesson over here, one of the things that you need to learn to do is to solve equations that are dealing with roots. Okay, so we're going to take number 56 here, and we're going to try number 56. It says the third root of 3t plus 1 is equal to -2. All right, so the first thing that you want to do to solve this is ask yourself, how can I free up the t, right? So number 1, the t is being multiplied to 3. Number 2, that 3t is being added to 1. Then number 3, there's a third root of all of that. So what you want to do when solving this equation is you want to begin by removing that third root by cubing both sides. Just like a square would remove a square root, a cube would remove a cube root. So you end up with 3t plus 1 is equal to -2 cubed, which is -8. And then if you subtract 1 on both sides, or basically bring the 1 over, it will become 3t is equal to -8 minus 1, which is -9. And then you can divide by 3 on both sides. Even that step, we start showing that very little as we proceed through algebra, because everyone understands that step. So the answer to number 56 is -3. All right, let's try another one. Number 58, it says the square root of 12 minus x is equal to x. So you want to ask yourself, how do I get rid of these following things, right? Here's the x right over here, and here's an x right over here, right? So there's 2 x's. And you got to ask yourself, okay, how do I get these x's onto one side? Well, one of the ideas is to first move this x over, but you can't move it over until you don't get rid of a few things that are bothering it. For one, there is a -1 on the x, right? Look at that negative sign right there. There's a -1 on the x, so think about, how do I get rid of that? Then you do 12 minus the x, or you could say 12 plus the -x. Then there's a square root on it. So you got to really get rid of 3 things before you can even think about getting the x onto one side. So always start from the big picture and be like, okay, how do I get rid of this square root? Because that seems to be causing all of the problems there. Let me just remove these for a moment. So we're going to find ourselves squaring both sides, right? If you square both sides, that'll remove the square root. And now you have 12 minus x is equal to x squared, right? Now what we're going to do is we're going to notice that one of the terms says x squared, one of the terms says x, and this should ring a bell for you that whenever you have a x squared term and you have an x term, this is really going towards the quadratic. Ax squared plus bx plus c is equal to 0, right? So we're not going to be able to just add and subtract x's as we normally would have, right? So we need to do a little bit more. So what we're going to do is we're going to move everything to one side. Oops, sorry about that. We're going to move everything to one side so that we can focus on solving this equation, right? Which is, now we know that this is actually a quadratic equation. If you don't understand, how do you tell if something is quadratic? The moment that you see an x squared term, you know that this is quadratic. The fact that it's got an x on it too means it's going to be solved using most likely the quadratic formula, okay? So let's go ahead and see if we really need the quadratic formula or not. Now, what you want to generally do is you want to make sure that the x squared keeps its positive, right? You want to keep this positive, right? You don't want that first term out there to take a negative on it. So what we generally do in algebra is we say, okay, let's move the negative x and the 12 over to the other side, right? Let's move both of these to the other side. So what's going to happen now? You'll have a 0 is equal to x squared plus an x, because when that negative x comes over to the other side, it becomes a positive x. And when this 12 comes over to the other side, it becomes a negative 12, right? Now, this is a very awkward way of it being written because we're accustomed to a quadratic looking like this, right? It's got the equal 0 on the right side, not on the left side. So because it is a bit awkward to write it that way, what we generally will do is we'll say, okay, let's just go ahead. We know that it's equal to 0, but what we'll do is we'll put the equal to 0 on the right side right now, right? So if you're wondering why didn't you just do that in the beginning, it's because then you would have gotten confused. You would have been like, wait, if you moved everything to the right side, then how exactly is still everything on the left side of the equation? You get it? So I moved everything to the right. It said 0 is equal to whatever, and then I went ahead and I simply put the 0 on the other side. You're totally allowed to do that in algebra. Now, before you factorize, always check, before you use quadratic formula, try to see if you can factorize this really quickly. And so can you think of two factors of negative 12 that add up to positive 1? And here's the two that I can think of. X minus 3, x plus 4 is equal to 0. Therefore, x is equal to 3, and x is equal to negative 4. And by the looks of it, we have reached our final answer. You're welcome to check the solutions. If you check the solution, the first solution is a 3, so check, is 12 minus 3 square root going to give you 3, yes or no? All right, so let's see here. 12 minus 3 is 9, and the root of 9 is equal to 3. So that first solution checks out. Now, I always get this question from students, wait, do we always have to do that? No, I'm doing this to help you understand that it works, right? So let's try the second solution. The second solution was a negative 4. So 12 minus a negative 4 is equal to negative 4, right? We're just plugging in the 3's in the spot where the x's were, and then the negative 4's in where the spots where the x's were. So now when you do this, notice how this and this become positive, right? So it becomes 12 plus 4. And if it becomes 12 plus 4, that's actually 16. And the question is, can 16 ever equal to negative 4? Yes, absolutely. Can the root of 16 be equal to negative 4? Absolutely. You can have a particular solution where you say the root of 16 is positive 4 and it's negative 4. Okay, so negative 4 is a perfectly valid answer. So moral of the story, both of these solutions are working solutions. In Algebra 2 and in Pre-Calc, you'll find that you need to check your answer because quite often what happens is you can have something that is an extraneous solution. All right, let's keep moving to the next standard. This one's a very tricky one. It's going to stay with you until really as you move into college, actually, especially if you're into engineering and stuff like that. So watch carefully. So notice how these are really numbers as you normally have seen them so far, right? It's like the number 4, the number negative 27, so on and so forth. So it's the same numbers as usual. However, we're noticing that the exponent there is a really weird looking one, right? It says 3 over 2, it says 1 over 3, it says 3 over 4. So what's the deal with that, right? So let me give you guys first a little bit of a background. First off, these are called rational exponents. All right, these are called rational exponents. And to work with the rational exponents, basically, here's what you do. You'll have a variable, let's call that variable x, and it'll be to the exponent that you can think of it this way. Power over root. Think of it that way. Okay? So when I say power over root, what that really means is the number that is on the bismillah, on the denominator of that exponent, that becomes the root, and the number that is in the numerator of that exponent becomes the power. So that's why I generally tell students P over R or power over root, okay? And I'll give you an example in a moment just to help you clarify all that out, right? There's another way to think of it, all right? So these are all equivalent understandings of it. You could also say the root of x, and then you can put it to a power. So what I generally tell people is this. I tell them either you can do power first, and then you can do root later, or, all right, so power first, root later, or in this second option, you can do root first, so find the root of the number first, and then do the power of it later. And really, it comes down to whether you have access to a calculator or not. It also comes down to the time that you have. When you see this, this is upper level math right here. When you see this, you'll notice, okay, which technique is going to work for me better here. So let me give you guys a number of examples. This is it takes a little bit to understand it, but inshallah you will. So number 60 says 4 to the power of 3 over 2. Now, I know I say power, but, you know, there's a lot more to it, we realize, right? So now, you can either write 4 to the power 3 over 2 as the second root. I'm going to emphasize this by putting the number 2 right here. Okay, so that number 2 is going to show up right here inside of the root, i.e. it's a second root, it's a square root, right? And then you write down 4 cubed, all right? So you ask yourself, can I do this question? Can I go ahead and find what 4 cubed is and then take its square root? If you can, go ahead and do it. All right, go ahead and do it and you'll be done. However, if it is too difficult for you, if it's too tedious, and the reason why I say that is because many times in calculus, when we see this, we don't have a calculator to it. We don't have a calculator in our hand, right? So then the other flexible way of doing it is the following. It's to basically find the second root. Okay, you're still finding the second root. Please understand that part. You're still finding the second root of 4, but what you're doing is you're putting it to the power later. All right? So either you can go bismillah, power first, root later, or you can go root first and look at these parentheses right here and then power later, right? So it's your call, whatever is easier for you. We'll do it in both ways here. So if you were to find 4 cubed, you will have found that it's 64, and the square root of 64 is 8. All right, so that's one way to get it done. The other way to get it done is to have said, all right, I'm going to find the square root of 4, and what's the square root of 4? It's 2, and then 2 to the power of 3 is equal to 8. So notice how you get the same exact answer, but you got to ask yourself which one is easier for me and pick the easier option. Okay? Let's go ahead and try, bismillah, let's try number, I'm going to try number, I think 64 might be worth our time, right? So let's try number 64. Number 64, it says 25 to the power 3 over 2. Again, give it some thought. Which one is easier for me? I personally am going to do both of them because I'm teaching you. So I'm going to do power first, 25 cubed, and then second root later, right? Because that says 3 over 2. And so we're going to be taking a second root of 25 cubed. So 25 cubed, second root, again, just for emphasis, if you like, I can put the 2 where it belongs. And now, again, you ask yourself, wait a minute, 25 cubed, isn't that a lot of work to do, right? So I'm going to leave this here. That's a lot of work. Pretend you didn't have a calculator, please, okay? So if you're a fan of the calculator, you're going to find that many times you don't have access to it when it comes to the questions. So it's like, okay, that's a lot of work. I'm going to skip over that. Let's think of the other option. The other option is to do root first, so find the second root first, and then whatever you answer you get from that, cube it later. And see how this is actually easier. So when we do this option, we're like, okay, what's the square root of 25? And the square root of 25 is 5, right? So now what is 5 cubed? 5 cubed is 5 times 5, which is 25, times 5, which is 125. So see how much easier that was. Without a calculator, you were able to come to that conclusion. All right, let's do one more here. We're going to try number 70. Okay, number 70 here. Number 70 says 8 to the power 27. Sorry, 8 over 27. I apologize. 8 over 27. And it's to the power of negative 2/3. Okay, so the first thing that you want to do is you got to realize, wait a minute, this is a fraction, right? So what do I do now? So let's take a moment and let's talk about what you do if you had a fraction. A over b to the power of any exponent, recall, becomes a to the power of n, b to the power of n. So this is the rule for exponents that we had learned earlier, and we're applying it. We're like, okay, so this is technically 8 to the power negative 2/3 and 27 to the power of negative 2/3. You see how I did that? I distributed that n value to both the 8 and the 27. Now the next problem that we experience is the fact that both of these have negative exponents. We don't want those. So what we're going to do is we're going to put the 8 to the power negative 23 in the denominator, and that'll make it a positive exponent. And we'll put the 27 to the power 2 over 3 in the numerator, and that'll give it its positive exponent, right? So people always say, oh, you flipped this. No, we didn't flip it. We just looked at where the thing had a negative exponent, and because the 8 had a negative exponent in the numerator, we brought it to the denominator. Because the 27 had a negative exponent in the denominator, coincidentally, we brought it to the numerator. So like that, right? Now, let's go ahead and think about this question. Basically, this is two questions in one, right? The top one is saying, can you find the cube root of 27 squared, or can you find the cube root of 27 and then power later, right? Then let's look at the bottom, right? The bottom is saying the cube root of 8 squared, or it's saying the cube root of 8 and then power later. You'll find that this power later thing actually comes in very handy, because who wants to sit there figuring out what 27 to the power of 2 is, right? So it's a lot easier to ask yourself, if it's possible, ask yourself, well, can I find the third root of 27? And you certainly can, based on the homework and stuff like that. You guys will remember that the third root of 27 is simply 3, so you get 3 squared in the top. And the third root of 8 is 2, so you get 2 squared on the bottom. And what's 3 squared? 3 squared is 9. And what's 2 squared? 2 squared is 4. And so yet again, we are done with this question. All right, so that is the skill called rational exponents. And I've done 3 of the examples for you. And basically, just remember that rule that I've written at the top of the line there. That's number 1. And number 2, just remember that whenever you do have a negative exponent, that's nothing to freak out about. Just go ahead and move it to the denominator or the numerator, and it's going to sort things out for you. I just want to make a little note here. If you're looking at number 66, notice that to turn that negative exponent into a positive exponent, all you need to do is just write it as 1 over 16 to the power 3 over 2. Yes, when there is no numbers that are going to be remaining in the top, you leave a 1 there. And now the 16 is happy, it's got a positive exponent, and you would go about doing what you just did in number 70. Okay, so that was the next objective of this lesson, to be able to work with rational exponents. Now this third objective in our lesson, it really comes in kind of at an awkward spot here, and let me explain to you what happened here. really this objective right here that I'm about to teach you, it was supposed to have been done first. Okay, it was supposed to have been done first. It was by just cutting and pasting errors, because notice how this starts from number 59, these start with number 43. This was supposed to have been done first, and then this was supposed to have been taught later. But inshallah khair, we're not gonna change that now. So let's go ahead and learn the next objective. The next objective is to work with something called rationalizing the denominator. Okay, so just a little bit of background for you. In the previous lesson, what did you learn? All right, you learned to add and subtract, right? You learned to add and subtract roots. You learned to multiply. You learned to multiply roots. But you never learned to divide roots, right? You never learned to divide roots. So this right here, this topic is going to be about dividing roots. Okay, that's really what's happening. If you look in all the questions that are in front of you right now, every single question has a commonality, is it's got a root, right? It's got a radical in the denominator. So I'm going to be teaching you, and usually if you can do a root division problem, you can do all of the other problems too, kind of a thing, right? So I'm going to be teaching you how do you actually divide roots, all right? So bismillah, let's go ahead and start with this inshallah. We're going to start simple. Okay, we're going to take something that most of you are familiar with because of trigonometry. So 44 says 2 divided by root 3. That's all it says, right? It doesn't say anything else beyond that. Again, the topic is called rationalizing the denominator. And rationalizing the denominator simply means to do the following. Okay, it means multiply by what's in the denominator, right? The root in the denominator was a 3. So only use the root part of it, right? So you multiply on the bottom and the top by root of 3. Okay, now I just want to say one thing before we move on to solving this. What did I just multiply by? Think about it, right? What did I just multiply by? What's the root of 3 divided by the root of 3? It's 1, right? So what's 2 over root 3 times 1? It's just itself. So that's a cool property of math that we can use to get things done, is what we'll say is, okay, I'm not doing anything. I'm just multiplying by the same thing over itself, right? But what we all know is it is causing some changes to occur, right? So here's what's going to happen. In the top, you'll take the 2 and the root 3 and you'll multiply them, and you'll say, okay, the top is 2 root 3. In the bottom, you'll take the root 3 and the root 3 and multiply those, and you'll automatically say, well, the root 3 times root 3 is root 9, which is actually 3. Always ask yourself at the end, did I get rid of the root on the denominator? If you did, right? If you did, then chances are you rationalized correctly. If you didn't, then chances are you messed up the rationalization. The end of rationalizing the denominator is the denominator needs to be something that is just a number, because rationalize, right, means to basically make it into something that is a rational number, okay? And I'll just have you know that there is something called irrational numbers, and an irrational number, an example of it would be the root of 3. Because if you find the root of 3 in a calculator, you don't get a certain integer. You don't even get a run-on decimal. You get some crazy looking decimal number that has no patterns to it, right? But a rational number has a pattern to it. So we stick to rational numbers. That's just something that we agree on, all right? Now let's try another question. We're going to jump ahead to bismillah, number 48 here, okay? We're going to try number 48. Now what do you do when you have 2 terms in the denominator? So notice how in number 48 there's 2 terms, right? Whereas in number 44 there was only 1 term. There was only a, bismillah, there was only a root of 3 in number 44, but in number 48, there's 2 terms. So I will be showing you now what do you do in that situation, all right? So Bismillah, number 48, it says the root of 2 divided by the root of 7 plus 2. Now what do we do? All right. So step number 1, you make a multiplication sign. Okay. This time when you multiply by the root of 7 minus 2. Okay. The root of 7 minus 2. Now that technique, okay, is called multiplying. You have to know these words. Multiplying by the conjugate. And a conjugate is basically what you're looking at. It's basically the same 2 terms, but instead of an addition sign, you got a subtraction sign there, okay? And you will see shortly what that is going to do for you. It all just depends on how much you focused on that previous homework, though. So you're multiplying the root of 2 times this over here. All right, I've kind of kept it in color just to help you out. And then you're multiplying the root of 7 plus 2 multiplied by the root of 7 minus 2. Okay? All right, so a handful of tricks here. Notice how this is in the format of a plus b times a minus b. And in that previous lesson we talked about this. We said if you get a plus b times a minus b, a very handy trick, instead of doing that whole problem, is to realize that that actually gives you a squared minus b squared. Okay? You are welcome. You are welcome to try it by yourself using FOIL method. Say a squared, right? Bismillah, minus ab plus ab minus b squared. If you use the FOIL method, this is what you would have gotten. But you'll notice that the 2 middle terms cancel out. And so guess what? You'll end up with a squared minus b squared. So that's just a little side note for you, okay, just to help you out to get through as quick as possible a problem like this. So now here's what we have. We have the root of 2 times the root of 7. Now go back to you can pause here and be like, okay, how do you multiply roots? So when you multiply roots, as long as we said the root is the same and the radicand is the same, right? These are both second roots. Sorry, not the radicand, just the roots are the same. As long as they're both second roots, you're allowed to multiply what's on the inside of them. So the root of 2 times the root of 7 gives you the root of 14. Okay? Now the other one. The root of 2 times negative 2 is going to give you minus 2 root 2. Notice how this time the 2 is going to show up on the outside, right? It can't multiply to the inside. That is against the rules of roots and of algebra. Now on the bottom, just to speed things up, because of the idea of a plus b, a minus b, you just go straight to a squared minus b squared. If you're not comfortable with that, if you've never seen this before, if you're like, wait, where did you get that from? You are welcome to do what you did in that previous homework and distribute the root of 7 to the root of 7, the root of 7 to the 2 to the root of 7, and the 2 to the negative 2. You're going to find that what I'm going to write here is going to be the same answer, okay? You can pause the video and try it by yourself, please, all right? So you have root of 7 squared minus 2 squared. Again, the idea is a squared minus b squared. All right, whenever you have a plus b, a minus b, it goes to a squared minus b squared. Okay, now let's see where this goes. All right, so in the top, we have root of 14 minus 2 root 2. In the bottom, we have, Bismillah, the root of 7. When you square it, what do you get? You get 7, right? And 2, when you square it, what do you get? You get 4. So 7 minus 4. And so our final answer here is the root of 14 minus 2 root 2 divided by 3. Now, as we finish this up, ask yourself one question. Did I get rid of the root on the denominator? And look at it, I have gotten rid of the root. Okay, so why does 44 and 48 once again look so drastically different? It's because the technique which you use in 44 is for a 1 term, in 48 it's a 2 term. Okay? All right, now let's try number 50. Okay, number 50. You have everything in your pocket for you to try it by yourself. So if you wish to pause the video, I would really recommend, instead of just watching it, to try it by yourself and see how that goes for you. All right, so let's give number 50 a shot. All right, bismillah. We've got the root of 3 minus 1. And in the denominator, you've got 2 root 3 plus 3. Step number 1, multiply by the conjugate. And if you're wondering why is the conjugate there again, it's because of the fact that if you go back, you'll realize this is 2 terms we're looking at, right? You got 2 terms here. You got 2 terms, you're always going to multiply by the conjugate, right? So 2 root 3 minus 3 in the bottom and the top. Notice how I changed the plus sign to a minus sign, okay? Now, you really want to make use of the a plus b, a minus b technique as we're going through this. First, let me write out for you what we're going to be working with. I will refrain from writing this in color because it's going to take a lot of time. So here is the top, right? We're multiplying fractions, so you just multiply the 2 tops. And here is the bottom, all right? Here's the denominator, 2 root 3 plus 3, and then 2 root 3 minus 3 like that. Okay, now, where are we going with this? Again, you want to save as much time as possible, otherwise you really start to mess up with and get bogged down by time in upper level math. So this is a plus b, this is a minus b. You want to quickly make that connection and say, well, that would lead to a squared minus b squared, right? And I'll write that again in a moment, but just for now. All right, so now let's focus on the top. Okay, the bottom is going to be quite predictable because of how we manipulated it. Let's focus on the top. Now, if you don't know how to work with the top, it's quite likely that you didn't understand the previous homework. So you should stop and review that previous homework first. Okay, so here goes. First, we're going to multiply the root of 3 with 2 root 3. But we're going to try to do this as quick as possible. Okay, again, the root of 3 multiplied by 2 root 3. Well, the multiplication rule says you are allowed to multiply 2 roots that are the same, right? They have the same exact root in them. So this is the second root, this is the second root. And so you can say that this is actually 2 times the root of 9. And 2 times the root of 9 is actually 2 times 3. And 2 times 3 is 6. So what that means is we can say, all right, we know the answer to the first piece. We're going to end up with 6 as our first one. Now let's go to the next one. Now we're going to multiply the root of 3 to this one over here, this negative 3. All right. Now what do we get? We're going to end up with minus 3 root 3, like that. All right. All right. Now we're going to go to a third one. All right. And in the third one, what we're going to do is we're going to multiply the 1 to the 2 root of 3. All right, so we're going to multiply this 1 to that 2 root of 3. Notice how there's a negative out front. So that's going to become negative 2 root 3 like that. And finally, the last one, the easiest one, is negative 1 times negative 3, which gives you positive 3. All right, now let's focus on the bottom. In the bottom, again, you want to save yourself as much time as possible. We know that this was of the format a plus b, a minus b. By the way, every time it's going to be like this because of the way that you come up with the conjugate, right? Whatever this was, the other one is just going to be the same thing with a subtraction sign, right? And if this was, by the way, a subtraction sign, if that was a minus sign, then this would be a plus sign, right? So let's go ahead and write this out. So you really are going to have 2 root of 3 whole squared minus 3 squared, like that, right? So now ask yourself, how am I supposed to work with this? And what I'm going to do, I'm going to pull that problem out to the left here so we can continue with it. And so in the top, you're going to have negative 3 root 3 and negative 2 root 3. Now notice how these are being added and subtracted, right? So you got to ask yourself, what is the rule for adding and subtracting roots? Remember, that was a lot more conservative. It said that not only does the root need to be the same, the radicand, the thing inside of the root, needs to be the same. So so the question is, can we go ahead and combine these? And yes, we absolutely can, because both the root are a second root and they both have a 3 inside of them. So this part right here is going to become minus 5 root 3. But there is more. There is more. Notice how there's a 6 on the left end and there's a positive 3 on the right end. Those can combine to make a 9. So in my next line, I'm going to write down 9 minus 5 root 3. Right? That's representing a lot of work right there. And in the bottom, you ask yourself, what's 2 root 3 squared? Right? So if you don't know how to do this, 2 root 3 squared means 2 root 3 multiplied by 2 root 3. Right? Now, the outsides multiply to the outside, so you get a 4. The insides multiply to the inside, so you get a root of 9. And then that becomes 4 times 3, which is 12. So when we go back, we write in a 12 in the spot. All right, and finally, the other piece is relatively easy. 3 squared is 9, so 12 minus 9, like that. So you end up with 9 minus 5 root 3 over 3 as your final answer. And you'll observe that that was an incredible amount of work to do to actually come to the answer right there, okay? Now I know how difficult this topic can be, so I'm going to try another question with you, and the hardest one in the set, which is number 54, okay? Let's just face it, you know, in real life you're not going to see really any of these problems, but you know, to just kind of get an idea of how upper level math works is really quite rewarding. It makes your mind grow too. Let's actually do number 52 and then we'll do number 54. So number 52 says that you've got negative 2 divided by the third root of 9. Okay? Remember, the objective is to get rid of the root from the denominator. So here is a common mistake students will make. They'll say, well, this is what Brother Austin was doing the whole time, so I'm just going to go ahead and do that. I just want you to pause and think about that. Okay? Just think about why this is wrong. All right? Look. If you were to take the third root of 9 and multiply to the third root of 9, what would you actually get? You would actually get the third root of 81. That's not a perfect third root. And because it's not a perfect third root, guess what? You haven't fulfilled the objective. Your objective was to get rid of the roots from the denominator. That hasn't been done yet. What I'm trying to say here is, in fact, what you need to do is you need to multiply by third root of 9 like this over here. And you will see shortly why we do that. Okay, so on the top you're going to have negative 2 third root of 81. All right, and in the bottom you will have third root of 9 times 9 times 9. Think about it. Remember how we used to do roots? We used to say we need to look for sets of 3. Well, how many sets of 3 do you have? You have a set of 3 9s, so you can pull the 9s out. And now we have successfully gotten rid of what? We have gotten rid of that root that was in the denominator. You see how I did that? And that could not have happened if you had simply multiplied once by the third root of 9. So a good trick is to think of it this way. If this said fourth root of 9, you would have put 3 more fourth roots of 9, so that altogether you would have 4 fourth roots of 9, right? Like that. Okay, now let's focus on the top here in the numerator. This can definitely be simplified a little bit further. This becomes negative 2 multiplied by the third root of 81. And if you want to think of it this way, 81 is the same thing as 3 times 3 times 3 times 3, or you could have thought it as third root of 27 times third root of 3, but I acknowledge that that's not, you know, it doesn't come to everybody right away, so I didn't use the quicker method to do this. So you have 9 over here, and again, you're looking for sets of 3, is what we did in that previous homework. And so the sets of 3, you can pull out one single set of 3, so you'll have negative 2 multiplied by 3 third root of 3, and in the denominator you have a 9. You can still simplify this a little bit further. The 2 and the negative 2 and the 3 can make a negative 6. All right, so you've got a negative 6 right here. And then you've got a third root of 3, and then you've got a 9, and guess what? You can still simplify this a little bit further. Notice how the 6 and the 9, which are neither one of them is inside of a root, right? The 6 and the 9 are divisible. It's like, if, for instance, if you had a fraction 6 over 9, what would you simplify it to? Well, then you'd still do the same thing over here. So the 6 over 9 can both be divided by 3, and so this final answer that you get with all that work is actually the one that you're looking at right here. All right, let's keep rolling. Now we're going to do number 54, the one that I promised you earlier. So number 54, yes, initially it looks very intimidating, okay, because you're looking at a root plus another root, okay. Now, just a little note on that, you can't actually add those roots, and think about why you can't add those roots. It's because even though they do both have the second root, unfortunately, one of them says x plus h and one of them says x minus h. You can't do that, right? So it's not going to work, all right? Another thing that students have said in the past is they've said, hey, why don't we cancel these x plus h's and these x minus h's? That is improper. You can't do that in algebra. Like, for instance, if you had a plus b, right, over a minus 6, you can't just say, yeah, I'm going to go ahead and cancel those a's out. That doesn't work. Okay, so that's not a rule of algebra. This is not algebra. It's it's something that we think is true, and I can even share with you why. We think it's true because AB times negative 6A, you could have canceled the a's there, right? When they were being multiplied. This is algebra. That's algebra. You can do that. But when they're being added or subtracted, yeah, you can't do anything with it. As much as you want to, you can't touch them, right? So let's get rid of misunderstandings first. No, you can't cancel the x plus h's and the x minus h's, right? No, you can't add what's inside of the roots. It's simply because the x plus h and the x minus h are not the same radicand. You need the same radicand in adding and subtracting roots for that to work. So that leaves us with the following option. We need to multiply by the conjugate. Now you might say, wait a minute, what's the conjugate here? Look, here's one term, as big and enormous as it looks, and here's the second term. There's two terms. So the conjugate of two terms is always going to be the same two terms. So x plus h, x minus h, the same two terms. However, what did I say earlier? You put an addition sign. If there was a subtraction sign there, its conjugate is going to be an addition sign. So go ahead and copy that in the denominator and the numerator. So that's one of the cool things about algebra is no matter how simple or how difficult the problem gets, as long as you stick to your rules of algebra, you will arrive at an answer. Okay, and that's one of the reasons why people really like algebra, because the rule sticks, right? It's not like all of a sudden the rule changes when the problem gets harder. Okay, now we're going to be working with the top there, and because I want to refrain from writing the top again, please realize that we're going to be taking this and multiplying to this. And then we're going to be taking that and multiplying to that, okay? Furthermore, if you skipped over any part of the video or if you missed the video and did not understand it, you want to pause it right now. Otherwise, this will just pass over your head. And you want to go back to where I talked about a plus b, a minus b, or in this case, a minus b, a plus b. Ask yourself, where does that lead to? All right, so a minus b times a plus b is equal to what? A squared minus b squared. It's a very handy formula, and you notice that firsthand when you're trying to do a question which is this complicated. All right, now bismillah, let's get started. We're going to start with the first one. Okay, so what are we multiplying? We're going to multiply the root of x plus h and the root of x plus h. Now you think about what I just said there. I said the same thing twice, didn't I? Right? I said the root of x plus h times the root of x plus h. Think of it this way. Back when you had the root of 5 and the root of 5, what did you used to say the answer was? 5, right? So what's the root of x plus h times the root of x plus h? It should still just be x plus h. So the top is going to become x plus h, all right? Now that was simply the first two terms where we are multiplying two terms with two terms. So now the next things you have to multiply is the root of x plus h times the root of x minus h. That unfortunately does not have a quick fix. You just need to go ahead and write it out, all right? So I'm going to go ahead and put an addition sign because both of them are positives. I'm going to write down root of x plus h times the root of x minus h, like that, okay? Now let's keep moving to the next one. Now what we're going to do is we're going to multiply the root of x minus h to the root of x plus h. And if you think about it, that's basically the same thing as we just did earlier, just in the different order. And recall, in multiplication, the order does not matter. And so you can simply write down the root of x plus h again, and the root of x minus h. I want you to think about it. Notice how this right here is the same thing as that right there. What can you do in algebra when you have two of the same terms? All right, just think about it. All right, but we'll simplify at the end. I just want you to have some forethought before we do so. Okay, the last one that we're going to do is we're going to do the root of x minus h right here times the root of x minus h. Notice how they both once again have positives on them. So when you do something like that, with the same logic as I showed you over here, if you have the same exact thing inside of the radicand, then the radical sign itself just kind of is gone, as long as it's just the square root. So you're going to end up with plus x minus h. For anybody who doesn't get that, x minus h are the same thing. So you end up with x minus h as your answer to that piece, okay? So observe the top, okay? Pause it, work through it if you wish, that's fine. This problem takes a while for people to do. If you're wondering, well, then how are you doing it? It's because I've been doing it for so many years, alhamdulillah, right? Now, let's look at the bottom here. The bottom, the denominator says a minus b times a plus b, right? So we really want to utilize that a squared minus b squared formula and say, well, you know what? I don't want to run through the whole FOIL method all over again because you guys just saw how long that actually takes to do. So what I'm going to do here is I'm going to write down, okay, here is my a root of, I'm talking about the denominator, by the way, root of x plus h. I'm going to square it. Again, I'll put it in green. That's the equivalent of a squared. And then the other one is the root of x minus h, and that is also squared, so that's the equivalent of b squared. All right? Now, we're going to have a little game here where we call just simplifying things. Okay, so look carefully. What can you simplify? And I'll try to circle it for you. So let's start with the top. In the top, you'll have an x and you'll have a x. Notice how they're both being added. And so let's start writing a final answer here. You're going to have two x's in the top. All right? Then notice how you have a plus h and a minus h. So they're both gone. All right? They've been eliminated. Then the middle, as crazy as it looks, there's not much happening here, right? I asked you this question earlier and I wanted to see what you thought about it. There's a coefficient of 1 here and a coefficient of 1 here. I just want you to think about if you had the root of x added to the root of x, what did we learn in that previous homework? It just becomes 2 root x. So as complicated as this looks, you're just going to write down that this is 2 times x plus h times x minus h. That's all you can say about it, okay? And finally, in the denominator, the root of x plus h whole squared, what is that going to do for you? That's going to cause this to become x plus h. And then the root of x minus h whole squared, what is that going to do for you? That's going to become x minus h. Now you want to be careful right there, right? It's easy to miss. Notice how there was a subtraction sign here. That subtraction sign is still there. Do you know what a subtraction sign does in a problem to everything that comes after it, right? It actually does something, and if you miss it for very silly reasons, you would get this wrong. So here is what happens in the denominator. You have x plus h, and then you have minus x, because the negative is going to cause the x and the h to switch signs. So minus x and then plus h, like that. And guess what? The x's now cancel out, and what combines is the h's. So you end up with an answer, and you know what? This is still not simplified, but we're almost there though. You have an answer that looks like the following. All right. And just a funny story, I used to do this example in the summer when it was maybe 90 degrees, 80 degrees outside at Salam School, when I used to teach summer school, and people used to lose their minds. They're going like, man, I just want to take a break now. And so now that you have a 2h there, notice how each one of the terms, term 1, term 2, right, they're all being multiplied, and term 3 all have 2's on them. Well, here's a convenient thing that you can do. You can divide everything by 2. You're allowed to do that algebraically. Many people don't know that. So if you want to know how exactly is that true, basically it's called factorization once again. You can factorize the 2, right? I took the 2 out from the problem in the top and in the bottom, and then I can cancel the 2's out. And then whatever answer you get left over is your final answer. All right? So I argue that anybody who can manage to do that problem right there is a champion and can do anything that came before it. All right? But I did take the 10 minutes to go through that problem with you. The third skill that we're going to learn in this lesson is called simplifying rational exponents. All right? If you want to call it that, right? It doesn't really have, one specific name. But before I start with that, right, I just want to remind you of something that you learned in the previous lesson, I believe in lesson number 1. I want you to think of it this way. If you had x to the power of 3, and it was divided by x to the power of 2, what did we used to do? 3 minus 2, which gives you an x, all right? Or what I told you is you can cancel 2 of the x's from the bottom with 2 of the x's from the top, and you'll be left over with 1 x in the top. What if we had x to the power of 5 divided by x to the power of 8, right? What would you do then? Well, it would still be top minus bottom, so 5 minus 8, but unfortunately now you would have a negative exponent. So what you would need to do is you would need to change that to a positive exponent by saying this is a 1 over x cubed, right? Recall that technique works very well when you say, well, there's 5 x's in the top, 8 in the bottom, so if 5 of the ones from the top cancel with 5 of the ones from the bottom, I'll be left over with just 3 in the bottom, right? So either technique works, but the one that we really want to focus on, this is why you shouldn't just have tricks in your mind. You should have rules, right? Like, how does it work, right? You should always ask yourself, wait, how does it work? You shouldn't just say, yeah, whatever, I'll figure it out later. So it's always top minus bottom, okay? It's always the top exponent minus the bottom exponent, right? So top minus bottom. That's how it always works, and the answer always shows up in the numerator. So having said that, we're going to do a problem that is quite involved, and I'm only picking one because of the length of this lesson already. I'm picking one to try here, okay? So you have x times y to the power 1/4. Then you have x squared times y squared to the power 1/2. Then in the bottom, you still keep going. You have x squared y, and then it's to the power of 3/4. I'll tell you what, the problem here does not really become anything more than people struggling with adding and subtracting and multiplying fractions because it's been a while. Okay, so we're going to be practicing that more than anything, right? So the first rule that we're going to use is the power rule that says if you have an exponent, notice how all three of these have exponents, all right? And they happen to be rational exponents. They're going to be multiplying in to every single one of these powers that you see here. So let me zoom in a little bit, right? So the 1/4 is going to multiply to the 1 and that 1. This 1/2 is going to multiply to those 2's. This 3/4, whoops, sorry. This 3/4 is also going to multiply to the 2 and then to the 1. All right, so here's what it's going to look like. We're going to have x to the power of 1/4, y to the power of 1/4. All right, you want to be convinced of that. Then in that second set, remember everything here is being multiplied to everything here. So you're totally free to just continue writing, okay? You ask yourself, what's 2 multiplied by 1/2? This is where things start to get a little hairy for students. What's 2 multiplied by 1/2? All right? And what you should get is 2 multiplied by 1/2 is 1, and so therefore you have x to the power of 1 like that. By the same logic, you'll also have 2 on the y multiplied to the half, so that gives you y to the power of 1. Now let's focus in the denominator. All right, in the denominator, you have 2 and 3/4 multiplied. I'd like to do this part just separately for anybody, because I remember at one time teaching your class and I noticed there was a bit of a struggle there, and I don't want you to struggle, you know that. So this is how you multiply a whole number and a fraction, is you make the whole number into a fraction. So 2 over 1 times 3 over 4, just a really quick way to do it. Okay, you'll have 6 over 4, which simplifies to 3 over 2. Or if you wanted to say 2 over 1 times 3 over 4, and then I cross cancel 1 and 2, you would still get 3 over 2. All right? Now, having said that, back to the problem here, it's going to become x to the power 3 over 2 like this. All right? And then this is quite easy. There's a 1 on the y, so 1 multiplied by 3/4 is simply 3/4. So here's what we're looking at so far. Okay, now what do we do? Well, once you've brought the problem this far, it actually gets a whole lot easier. What you need to do is follow the rules of exponents. It says if you're multiplying two things, right? If you're multiplying two things and they're the same variable, you add the exponents. So you add a and b. If you are dividing two things, and I already highlighted this for you, so I don't want to do it again, but if you're dividing two things, then you subtract the exponents top minus bottom. And so what's going to happen here is everywhere there is an x and an x, I'm going to go ahead and add their exponents, right? Because everything is in the top, everything is being multiplied. That means x to the power of 1/4 times x to the power of 1. So I'm going to go ahead and do that part first, right? So I'm going to have x to the power 1/4 plus 1. And then I'm going to do the same thing for the y's. So the y's is going to become 1 over 4 and 1. Again, when you have the same exact variable and you're multiplying them, you add the exponents. So there you go. That's what the x's and the y's look like. Now the denominator, we're not quite ready for it yet, okay? Because that says 3 over 2 and 3 over 4. Let's leave that alone for now, and let's go back to our drawing board. What exactly is 1/4 added to 1? And then that thing is still repeated. So again, if you tend to struggle with this, you will get a lot of practice with it in this lesson. You'll be forced to simply. So 1/4 added to 1 means you first find a common denominator, right? And the common denominator is going to be 4. So you end up with 5 over 4, right? Because 1 plus 4 gives you 5. So what you really have now is the following. You have x to the power 5 over 4, y to the power 5 over 4, because both of them had the same exact arithmetic there, right? Moreover, in the denominator, you'll have x to the power 3 over 2, and then y to the power 3 over 4. Now, you want to think about what do we do next? Well, in this situation, what are we left over with? We essentially have 2 of the same variable that are being divided, and then we have 2 of another variable that are the same and they're being divided. Now, what did we learn? Whenever you're dividing 2 variables, I probably have repeated this 5-6 times already, you need to subtract the exponents top minus bottom. So everything comes to the top, and you're doing the question 5 over 4 minus 3 over 2, and then 5 over 4 minus 3 over 4. Okay? Now, one of these does not have a common denominator, so let's just do it here. The common denominator of 4 and 2 is 4. So this x will become a what? Right? The x will become, bismillah, let me just clear this a little bit. The x will become a 5 over 4 minus 6 over 4, and the y will become a 5 over 4 minus 3 over 4, which is already a common denominator, so that's relatively simple. That'll simply become a 2 over 4. All right, we're almost done with this. What's 5 over 4 minus 6 over 4? It's negative 1 over 4. And y to the power 2 over 4 can be simplified to y to the power of a half. And think about it. What's the last thing that remains that we still haven't accounted for? The fact that you're not allowed negative exponents in your answer. And so to turn this into a positive exponent, you leave the y to the power of half in the numerator, and the x to the negative 1/4 comes to the denominator, and it looks like that right there. Okay? Well, for that particular objective, it doesn't require that I do every single question. It just requires that you guys get an idea, and then you can try a lot of the other ones the same way. I'm telling you right now, though, it really comes down to your ability to add and subtract and multiply fractions is what it really is. Okay? Now the final objective that we're going to cover is using a calculator to approximate each radical. I just want you to pick up a calculator with me, please. This becomes a real issue later on. I know this has become a long lesson, but believe it or not, this is a real problem for students. Because soon you're going to have the calculator that you're looking at, and you need to be able to work with this, right? So I'm going to pick a question here. Sorry. I'm going to pick a question here, and we're just going to kind of try it together, putting it all in a calculator. And the one that I want to try is number 85, okay? Just, how do you put this all in a calculator? Now, step number 1, make sure from here on out, whenever you're working with multiple terms in a numerator or in a denominator, so basically in a fraction, that you begin with a parenthesis, all right? So I'm going to write in 2 square root, so you find the square root from there. In the beginning, a lot of people don't even know where the square root is. So 2 square root 3 minus, now notice how that says third root of 4. Now where do you find the third root? You click on math, and you go all the way down to option number 4, and that is the third root of 4. All right? If you're wondering, what if it was a different root than a third root? Just to pause here, you would go to this option right here, and that option, you see how it says x? Then you can replace the x with any root that you want. Okay? Anyway, so back to the question here. We got 2 root 3 minus third root 4. I put that all in a parenthesis, and then I divide that by the root of 2. Notice how I'm not putting the root of 2 in parentheses because there's only one term there. You don't need to put it in parentheses when it has only one term. So the answer that you get is 1.327, and we've had many discussions about this in class. When you need to round to the first 2 decimal places, that's going to become 1.33. Okay? Now, a really quick note, I don't want to do number 84 because how long this lesson has gone on for. For number 84, just remember when you put it in a calculator, put separate parentheses for the top and for the bottom. Okay, so parenthesis, all the stuff in the top, parenthesis, all the stuff in the bottom. Otherwise, your calculator will misunderstand and you'll get the wrong answer. And students do that all the time. Okay? All right, the last thing that we're going to do in this lesson, and alhamdulillah, we have come to the end of one of the hardest lessons actually in Algebra 2, right? So it's very long, it's got a lot of rules to it. I'm going to try number 116 with you guys. And basically the question says that the period t in seconds of a pendulum of length L in feet may be approximated using the formula that you're looking at. All right. So if you don't know what a pendulum is, just really quickly, it's something that, it swings left and it swings right. I teach this in physics, so eventually you'll see it. But for now, we're just pulling the math out of it, and the math is important. Okay, you need to know it. So here goes. T is equal to 2 pi L over 32. Now, L is measured in feet. L is measured in feet. Period is measured in seconds. So it'll tell you how long it takes the pendulum to swing once if you give it the length of the pendulum, all right? Well, here's the problem. In number 116, they don't give us something that is in feet. They give us something in inches. So that's one of the reasons why I'm going over it. To turn inches into feet, you need to multiply by 1 foot divided by 12 inches. And the reason why we do that is that way you can cancel the units of inches with inches, right? Possible that Sister Afnan or Sister Sahar have taught you this. So this becomes 4 over 12, which becomes 1/3 feet. In other words, 4 inches is the same thing as 1/3 of a foot. And notice I'm doing this all without a calculator, okay? So now what I'm going to do is I'm going to plug in t is equal to 2 pi square root of 1/3 over 32, all right, which becomes 2 pi square root. Now, if you don't know, what do you do exactly when you have a 1/3 and a 32? Don't feel bad. A lot of students show up not knowing what to do here. Here's what you do. 1/3 is a fraction. It's dividing 32. So that's in fact 1 over 3 multiplied by 1 over 32. So that becomes 1 over 96, right? So in fact, what's inside of this root now is 1 over 96. Now, going back to a little rule that I taught you earlier, 2 pi can now be written, the root of 1 over 96 can be written as the root of 1 over the root of 96. Yes, you can split things up in algebra. If they both have the same root and they're a fraction, you can split them up like this, right? The reason why you would want to do that is because the root of 1 is a simple answer. It's simply 1, so you can leave that as a 2 pi. And the root of 96, you need to go ahead and find what is the root of 96, right? Now, if you want to go old school with this, I don't mind, just you need to be able to do this. Once again, I'm letting you know, without a calculator. Okay, so without a calculator, you need to be able to manage to do what I just did right there. All right, I just found factors, kept breaking it down. That's really the beginning of the lesson. And so the root of 96, right, is the same thing as the root of 1, 2, 3, 4, 5 2's, right? 5 2's and a single 3, all right? So when you're making a second root, you're looking for pairs. So this 2 and this 2 can leave and multiply so that you get 4, and you get 4 root 6. In other words, the root of 96 can be simplified to the 4 root 6. And now you can simplify the 2 and the 4 to 1 and 2. So it looks like pi over 2 root 6. You can even rationalize this denominator, but because the lesson has gone long enough, we will not do that. And the units are in seconds. All right. So that is the end of a very long lesson. And thank you for listening, inshallah. I hope that you understood. Please spend some extra time with the homework for this. It is a tough one. And inshallah, I will be posting the solutions to it eventually too. Thank you, and assalamu alaikum.